Today we will be learning from section 2.5 of your book. We'll start on page 76. Yesterday we learned to determine the length of a line segment on a coordinate plane. Today our objective will be to learn to find the coordinates of the midpoint of a line segment. The midpoint of a line segment AB is the point C that bisects the segment. Bisect means to divide into two equal segments. You can use a number line to find the coordinates of the midpoint of a line segment. Our midpoint formula for a number line is to take the point A, add it to the point B, and divide by 2. Basically, we're taking the average of the 2 points to come up with our midpoint, the point right in between. Let's try this. Find the coordinates of the midpoint of RS. We're going to use the midpoint formula we just looked at. A here is -10. B is -3. Our points R and S. We're going to add those two together. -10 plus -3 is -13. We're going to divide by 2. And we simplify that to -6.5. So the coordinate of the midpoint of the segment RS is -6.5. That will be the point right in the middle. You try it. Refer to the number line above and find the coordinate of the midpoint of the segment RT. R again is -10. T is at 6. We're going to add those two numbers together. -10 plus 6 is -4. We're going to divide -4 by 2, and our answer is -2. Our midpoint is at the point -2. Here's more practice for you. Use the number line to find the coordinate of the midpoint of each segment. Pause the recording, find your midpoints, and hit play when you're ready to check your answers. For the segment CE, the midpoint is 2. For the segment FC, the midpoint is 0. For the segment HF, we have -2. For the segment HC, -1. The segment AD is -5. The segment DB is 1. Segment CG has a midpoint of 3. Segment GB has a midpoint of 5.5. And segment DH has a midpoint of -3.5. A similar relationship is true for the midpoint of a segment on a coordinate plane. Here the midpoint formula tells us, on a coordinate plane, the coordinates of the midpoint of a segment whose endpoints are x1, y1, and x2, y2 will be an x value of the average of the x values, x1 plus x2 divided by 2. The y value will be the average of the y values, y1 plus y2 divided by 2. Let's try. Find the coordinates of M, the midpoint of JK, given that the endpoints J are -9, and K is 8, 3. Again, we use our midpoint formula. We add the two x values, 2 and 8. We divide by 2. We add the y values, -9 and 3. We divide by 2. And the midpoint is the point 5, -3. You try it. Go ahead and work with the endpoints -4, -3, and 6, 11. Pause the movie, and when you've got the solution, hit play again. The coordinates of N, your midpoint, again, we're going to add the x values, divide by 2, add the y values, divide by 2. We end up with the point 1, 4. Did you get it? Try these. -5, 1, 2, 8. Again, substitute x plus x divided by 2, y plus y divided by 2. Simplify, and we get the point -1.5, 4.5. Let's suppose that the point G, 8 minus 9, is the midpoint of a segment whose endpoints are F and E. We're asked now, if we know that coordinates of E are 18 minus 21, can we find the other endpoint, the coordinates of F? So let's let x1, y1 be the coordinates of F. Let x2, y2 be the coordinates of E, 18 minus 21. We're still going to use the same midpoint formula, and I'm going to plug in the values that I know. So in solving for the x coordinate of F, I'm going to take x1 plus x2 and divide it by 2. We know that the answer should be 8. I don't know the value of x1, so I'm just going to leave it as x1. I'm going to substitute 18 in for x2. Now I'm going to solve for x1. In order to do that, I'm going to multiply both sides of my equation by the value of 2. This cancels the 2 in the left-hand side of my equation and leaves me with x1 plus 18. When I multiply the right-hand side of my equation by 2, I get a value of 16. I now solve for x1 by subtracting 18 from both sides. And I get on the left side of my expression the x1, and on the right side of my equation, my subtraction leaves me with a -2. So the coordinate value for x in the point F will be -2. I'm going to go through the exact same procedure to find the y coordinate of F. My midpoint formula tells me to take y1 plus y2. I don't know y1, so I'll just leave it as a variable. I'm going to substitute -21 in for y2. Now I know that those two numbers added together divided by 2 should give me -9. So I'm going to write that equation, and I'm going to solve for y1. Again, I'm going to multiply both sides by 2 to get rid of my denominator of 2 in the left side of the equation. That will leave me with my numerator, y1 minus 21. When I multiply by 2 on the right side, I get -18. Now I'm going to have to get rid of my -21 in order to get y1 isolated. So I add 21 to both sides this time. That leaves me with y1 equals 3. So the y value of the coordinate F is 3, and the coordinate F is -2, 3. Let's try that one. Suppose K has a value of -10, 17, and it is the midpoint of a segment IJ. We know the coordinates of J are 4, 12. We want to find the coordinates of the other endpoint, I. Again, I'm going to use my midpoint formula. I know to find my y values, I'm going to add the two y's and divide by 2, and that should give me 17. To find my x value, I have to add my two x's, divide by 2, and that should give me -10. So I'm going to set my two equations up, and I'm going to simplify. Multiply by 2 on both sides of each expression. That will leave me with x1 plus 4 equals -20, and y1 plus 12 equals 34. I'm now going to subtract 4 on my left equation here from both sides, and I'm going to subtract 12 from both sides of my right hand or my y equation. That will leave me with a negative 24 for my x, and a 22 for my y. So the coordinate of I was that value. All right, we have our last example here, where S is 3 minus 3/4. That's the midpoint. We know one endpoint T is negative 2, 6. Find the coordinates of R. We're going to set the problem up exactly the same way. Replace our x2 with negative 2. Replace our y2 with 6. Solve both equations for the variables. Go ahead and try that. Put the movie on pause for a minute. When you think you have the coordinate of R, play it again and check your answer. Did you get 8 minus 15/2? Here's some more practice problems you can try. The coordinates of the endpoints of a segment are given. Find the coordinates of the midpoint of each segment. Again, go ahead and try these. Only way you're going to learn how to do it is by practice. Go ahead and hit pause when you've got the problem to try, and then play it again when you're ready to check your answer. Let's try 0, 10, and 0, 0. Find the midpoint. You should have found it to be 0, 5. How about 0, negative 6, and 0, 0? The answer here is the point 0, negative 3. Let's try 4, 12, and 8, 20. Did you get 6, 16? How about negative 5, negative 14, and negative 1, negative 8? You should have gotten the midpoint of negative 3, negative 11. Negative 1, negative 15, and 9, 15 should give you a midpoint of 4, 0. You should be really proud of the work that you're doing. Your homework tonight is on page 80 in your book. It's problems 4 through 30, the even problems.